For the global carbon cycle, we primarily focused on carbon dioxide, but methane is an important component of the global carbon cycle also, and it contributes disproportionately to global warming. Human activities are responsible for increasing methane concentrations in the atmosphere. The importance of this statement is that it's human activities that are responsible, and methane concentrations are actually increasing in the atmosphere. Now, on an absolute basis, methane is approximately 1.8 parts per million currently, and a little over 390 for carbon dioxide. So, on an absolute basis, CO2 concentrations are a lot higher than methane concentrations. But as far as greenhouse gases are concerned, methane is 23 times more efficient in trapping heat, and so therefore it has a disproportionate effect on the warming potential of the atmosphere. Now, as far as human interactions with the methane budget are concerned, we already talked about how there's some evidence in a rapid decline in methane concentrations approximately 12,000 years ago with the megafauna extinctions that happened in the Americas. Methane is produced during fermentation and digestion by a large number of animals, and the extinction of these animals led to a decrease in the sources of methane to the atmosphere. If we look at the past 1,000 years, these are changes over the last millennium in atmospheric concentrations of CO2, which we already covered, and methane. And these are from ice cores in Antarctica. So if we look here on time, this is in years, that CO2 concentrations were relatively constant at 750 parts per million, and then somewhere around the Industrial Revolution, we saw an increase in methane concentrations to the point that the units here, parts per billion, were at roughly 1,800 parts per billion, or 1.8, which is equal to about 1.8 parts per million. So, just like with CO2 concentrations rapidly increasing, we've seen a rapid increase in methane concentrations in the atmosphere. If you look at how much methane is accumulated in the atmosphere and its global warming potential, approximately 20% of all the warming that's occurred since the Industrial Revolution can be associated with the increases in methane concentrations. This is a figure that we looked at back in Chapter 2, and it shows the radiative forcing in watts per meter squared of different anthropogenic factors. And it's both warming side of things and cooling side of things, because some of the effects that we've had on the atmosphere have actually led to cooling on a gross basis. So if you take a look at the largest single source of anthropogenic warming, that's been due to the increases in CO2 concentrations shown here. But here's methane. And actually the increases in methane concentrations have had a large contribution to the total amount of net anthropogenic warming. You can see also, and just to go over it again, that aerosol accumulation leads to net cooling. For example, changes in clouds, and also differences in ozone concentrations, for example, can lead to warming. But the largest single source of CO2, and almost second to that, is going to be methane. So methane is really important in the accumulation of methane in determining average temperatures. The global sources and sinks of methane are shown here. And this is a table from Chapter 14, it's table 14.2. Here, instead of using petagrams, we're going to use teragrams, which is, and there's 1,000 teragrams in a petagram. So it's 10 to the 12th grams. It's just the unit that we're going to use for methane. And if you look at all the natural sources these days, we have 168 teragrams of methane that are produced. And almost all of those are coming from wetlands. And we've talked about methane formation in wetlands, how it's an anaerobic process, and how wetlands are a very important source of methane. Termites and ruminants, due to their digestion, release on the order of 23 teragrams of methane a year. So that's 168 teragrams that are coming from natural sources. Anthropogenic sources, we have at 428 teragrams of methane per year. Fermentation by cattle and rice agriculture are two of the big ones. And so in this case, just like we had megafauna before, it's fermentation by cattle that are a large source of methane. And rice agriculture basically effectively increases the amount of wetlands that we have in the world, and they're a large source of methane. So in general, we've got total sources that equal almost 600 teragrams of methane per year, and the sinks aren't quite the same as the sources. And those sinks are generally atmospheric sinks. Methane is relatively reactive in the atmosphere, and we've seen increases in general. When you take a look at this difference, we've seen increases in atmospheric concentrations in methane. So this is just some of the basics of methane, and important things to remember is that it's an anaerobic process that comes out of wetlands and digestion, and anthropogenically we increase the amount of methane by increasing the number of cattle in the world. There's somewhere on the order of 1 billion cattle in the world, and all of those are releasing methane. And we've increased the amount of wetlands by having rice agriculture, and those flooded fields work just like wetlands in releasing methanes. So to remember, it's an anaerobic process, and anytime we have anaerobic situations, that there's different terminal electron acceptors and we produce methane. And this is really important in sediments, for example, wetland sediments as well as lake sediments. And waste management is also important on another couple of issues. Landfills, for example, are anaerobic environments, and there's methane production there. Simply by having 1 billion cattle in the world, we've increased the amount of methane production because the digestive system of animals can be anaerobic and need to have methane production. So even though methane is strongly reactive, it reacts relatively quickly, its mean residence time is low, methane concentrations have been accumulating in the atmosphere.